Welcome to Shark and General Interest Seminar. I'm Isaac. I'm HPTC based at York University. Today we're going to talk about using multiple GPUs for machine learning. Even though I title it for the machine learning, it's generally speaking about deep learning and as well. So here is objectives. So I'll try to do this kind of objective in this seminar. Firstly, I'll try to guide a beginner user to run his or her codes using GPU on Graham system. Secondly, I'd like to introduce how to set up a job submission script for different machine learning frames, such as TensorFlow and PyTorch. Thirdly, I want to introduce several approaches in using multiple GPUs and multiple nodes, especially for those two, TensorFlow and PyTorch as well. And lastly, I will show you how to use Tensorboard for PyTorch because Tensorboard has been used with TensorFlow. So a lot of people don't know how to use TensorBoard for the PyTorch. So we're going to go through this kind of objectives with this kind of outline. So I'm going to introduce about, brief idea about the deep learning and parallelism. So deep neural network, I don't want to spend too much time on this kind of topic. So basically, we feed some input data into the network, and we'll expect to get the result at the end. As you may see, there are multiple layers, and each layer has a different nodes, we say. So it depends on how many nodes and how many layers you have. You may have so many parameters, so many data sets as well. Therefore, parallelism is key success for this kind of deep learning or machine learning jobs. So in this very famous MNIST classification problem, as you may know, machine learning or deep learning has been known well or performing well in this classification problem. So on the left-hand side, you can see the handwritten data or image will be fed into the network, and the network do something to work. And as especially we apply some models in the layers, and at the end of the day, we will know what's the kind of the number which is even written in hands and we recognized by the computer. So as you may see, we have lots of layers, lots of nodes in each layer. So it means lots of parameters. So we need to parallelize this one using some idea. There are basically two big paradigm for this parallelism in machine learning or deep learning. By the way, I'm gonna mixedly use the machine learning and deep learning because in this case, we don't specify any type of jobs here. So in general, I'm talking about, so please forgive me. Uh, there are basically two different approaches. One is model parallelism, and second one is data parallelism. Basically, this one is similar to the MPI parallelism as well, because MPI is another way to parallelize the job, right? So model parallelism is, as you may see here, we use the same data or we feed the same data for different models. So if I go back to here, so each chunk, as you may see, so each layer can be seen as a different model. So each layer, goes to different machine. So layer one goes to machine one, layer two goes to machine two. So whenever you went through the, this kind of layer, you may set up different models, which means you may use a linear model, you may use a convolution, you may use, many different techniques exist a lot. So you can use those kind of things. Anyway, so as you may see here, even though they started with one machine model, and then it will be splitted to different machines with the same data, and then it will communicate each other. Like there are many different ways, broadcasting or ring communication. There are many different communication techniques to update each other, and they finally got the answer at the end. And data parallelism is very similar to the domain decomposition. So we divide this data and then feed those split data into the same model. So machine one, machine two, machine three, machine four most likely have same program but with the different data. So there are basically two different approaches. Basically, running machine learning code or DL code on this kind of cluster system is heavily rely on what type of parallelism you're using. But in general, we are, I think it's much easier to think data parallelism. So I will based on data parallelism on this kind of seminar. Uh, in machine learning or deep learning, there are basically big two frameworks. We call it framework. One is PyTorch, the other one is TensorFlow. As far as I remember, TensorFlow has been known to everybody very well, long time. So as you may see in the first bullet, the most widely used framework, open sourced by, actually supported by Google. However, in these days, a lot of people lean to the PyTorch. So as you may see in the first bullet, it's written as rapidly growing in research community, because the reason is PyTorch is more close to or similar to the Python code itself. So as you may see in the middle, PyTorch has a benefit of this kind of easy expression and use. Relatively, I'm not saying TensorFlow is so difficult to learn, but relatively TensorFlow is difficult, more difficult than PyTorch. So there's some like first the gate is a little bit higher for the TensorFlow than the PyTorch. However, TensorFlow has been known long time, so it has more or more user community, I would say, than PyTorch. So means you can find easily a lot of libraries, a lot of written examples pretty quickly. And also TensorFlow runs on almost all architectures. So CPU, GPU, TPU, and TPU is a transition processor, it's or tensor processor. It's very, very widely used. But PyTorch is growing right now. So maybe hardware-wise, PyTorch has less kind of platform yet. In Graham system, I'm gonna talk about all the setup and everything based on Graham system we support in SharkNet. So please bear with me. So in Graham system, there's 1.71 is available and 2.30 available for TensorFlow as well. I'm doing this kind of things for a while, but one thing I noticed, and also the reason I set up this kind of seminar is this field is changing so much. So every version of this framework changes a lot. And also it's related with open source community as well. So there are a lot of libraries, a lot of modules actually developed outside of our community as well. So there are very much like lots of variation and lots of different syntax for every version actually exist. So it's kind of difficult to catch up what's the new one, what's the old one. So hopefully this this general interest seminar help you at least state of art version in Graham, not in the world. What I'm saying is in Graham system, so that you can run your code well. Briefly, PyTorch, TensorFlow, they have pros and cons. I already explained you. Um, in the perspective of programming, PyTorch supports dynamic graph. TensorFlow has static graphs. This is not quite right now because TensorFlow 2.0 and plus right now TensorFlow 2.4 is available outside, even though 2.3 is available in the Graham system. They also accepted or adopted defined by run or dynamic graphing system as well. So both are similar, but briefly, in general. So PyTorch can change its model while it's calculating, which means once you feed one data, and then in the next iteration, if you found some good loss, you can change your model. So then you're gonna drop the model or you're gonna drop the layers or whatever, and it can change it. But TensorFlow in general, they don't allow to do it because you need to set up everything when you start. So it's kind of difficult to adjust the different input as well, because whenever your input changes, TensorFlow must be written again but PyTorch has functionality or availability to modify its kind of model itself during uh, during the run. That's the difference between dynamic and static graph, by the way. I'm going to explain briefly about what kind of GPUs available in our Graham system. You can use a CPU, by the way, for the machine learning and deep learning, but machine learning type of jobs actually well running on GPUs. So that's why GPU has been used for this kind of job a lot. Graham system has a CPUs too, but I didn't write down CPUs here. Graham system has these three different types of GPU nodes. So as you may see, number of nodes, number of GPUs per node, and GPU type and node. And the node is the one you have to attach when you submit your job. I'm going to show you later. And there's a CPU GPU ratio recommendation. I will explain this one more time later. Uh, for each GPU job, we recommend you to have less than 3.25 CPU, which means you need to assign 3 CPUs for single GPU job. That's kind of recommendation for this kind of GPU job. Um, each machine has slightly different, specification. So as you may see, P100, V100, T4. Well, technically, T4 is the latest one, but performance-wise, V100 is the best. Why? Because as you may see, double precision, single precision, you can see that, right? The performance, which we usually refer to the speed-wise, V100 is Volta is much better than others. However, as you may see, V100 has very limited nodes, right? So total 560 GPUs, and it has only 70 nodes, right? So it's not easily available for everybody. So if your job is not related with the double precision, why you have to bother waiting in the queue to get the V100? So you better use like a T4. T4 has awesome performance in single precision. Well, 8.1 teraflops is still awesome. And also it has Tensor Core. So why don't you use T4 more? Because T4, we have lots of them as well, because it has more nodes, right? So it's much easier to allocate your job. So as you see, there are pros and cons. As you may see, T4 doesn't have a function for the double precision. And also P100 doesn't have function for the Tensor Core. Tensor Core, you can think about it as a very much like a unit to accelerate your matrix multiplication, something like that. So if you can use Tensor Core well, you can get your speed doubled. So P100, as you may see, the number wise, I mean the speed number wise and Tensor Core number wise, it's good. But unfortunately, V100 is very, very busy. So if your job is not related with double precision and even not using Tensor Core, then why don't you go with the P100? Because P100, we have lots of them, okay? And on the right-hand side, there is some benchmark performance. I took it from somewhere, so you can take a look at it. And to run your DL or machine learning code, you have to set up virtual environment. The main reason is most of machine learning code, running in Python code or Python language. So you probably want to import a lot of modules from here and there to run your Python code. But our system has been used for a long time and for so many different users. So we cannot easily, accommodate all types of packages you need. So instead of making all packages available in our system level, we give you the chance to run it by yourself. So which means you can make your environment, that's why we call it virtual environment, by installing, uninstalling whatever you need, right? So this is virtual environment. So all the jobs I'm gonna explain from now based on virtual environment. So virtual environment is kind of the tool Python supports. So here is the typical kind of, getting in, getting out. As I mentioned, this is kind of beginner level of seminar. So I need to do this kind of things for the beginner users. So if you already know this one, please bear with me. Anyway, source, I'm gonna tell you how to set up the virtual environment soon, but I'm telling you is you getting into the virtual environment by activating your like a file or your virtual environment, and you coming out of your virtual environment by typing deactivate. So activate, deactivate is kind of the tool you're getting into the virtual environment. For different framework like PyTorch and for TensorFlow, we need to have a slightly different approach, but virtual environment should be same. As you may see, you better load 3 key modules before you actually set up your virtual environment. You may notice that when you log on to Gram system, we are actually updating our default like a standard environment. So STD environment means standard environment, but this kind of machine learning jobs actually heavily rely on recent development. So you better use STD EMB 2020 instead of 2016. That's a default in this case, in our, Gram system. So you better load, 2020 and Python and SciPy stack. SciPy stack is the stack supporting NumPy, Panda, those kind of things already stack up in that module. So if you load like a SciPy stack, you don't need to call the matplotlib plot or sklearn, those kind of things are all included. So don't worry about it. And then as you see at the end, you have to do this kind of command line, virtual environment, no download the PT, then it will generate your PyTorch. Uh, well, PT is the name for the PyTorch because I'm going to install more package for the PyTorch. That's why I name it like that. But this screen is basically same for the TensorFlow later. Anyway, so PyTorch, we support wheels. This is another thing so you need to know if you're not quite used to Python. Wheels is kind of package maintaining kind of system. So what does that mean is, let's say you want to install PyTorch. Here's the torch, 1.7.1. Okay, so you want to install this one. And if you try to install this one without this kind of wheels, technically your package should find the appropriate path and everything libraries, and then will be installed. But problem is sometimes this level of system, which means Gram system, this level of massively parallel system is not easy to be modified by a single user. If you're a root user or system administration level user, you can do that. But usually for the users, it's not easily change the system level path or system level libraries. So our system admins generate the wheels, which is adapted, which is modified for our system already. So when you check this one and install it, the Python, we're gonna use this kind of pip install soon. When you use pip install this kind of things, the pip or package installation, program automatically try to find the wheels first. And if there's wheels, they'll try to install the one already modified for the system will be installed on your virtual environment. That's the kind of concept. So wheels are very important for us. If you don't have wheels and if you try to install it, there are so many problems happens. But you can always send an email support at computecanada.ca. We'll see that if the package is available, we'll try to make a wheels and support it for you. Anyway, so check the wheels. So there's a torches available. So I'm going to install this one. So before you install anything, if you're first time for the virtual environment, you better you better upgrade your, install tool first. The PIP is the install tool, I would say. And then we install this kind of things. So this no index means it's indicating we want to check the wheels first. And then you can check the installed version. Well, I didn't include all the like installation messages. It's well installed pretty well. So I can see the torch, audio, text, vision, those kind of things, all installed in our virtual environment. So TensorFlow is pretty much the same idea. So load the modules and make an environment. I named the TF because this is for the TensorFlow. You check the wheels as well for the TensorFlow. There are many different things you can try. But for the TensorFlow, we do have two separate TensorFlow CPU, TensorFlow GPU wheels. So if you want to test your code on CPU only, then you can do the TensorFlow CPU. But I believe most of them actually want to use GPU because GPU, if you tune it well, most likely GPU is maximum 16 times faster than CPU. So you probably want to use Yeah, 90% for sure. Sorry. GPU. So you have to, install TensorFlow GPU, these kind of things. As you see, the version 2.3.0 is available right now. But as you may see on the right side and the column here, Python, as you see, Python 2, Python 3 actually supporting these wheels. So for the different Python level or different Python version has different wheels. You have to be careful. But when you do this kind of module Python here, you see here, Python 3.8 is automatically loaded. So most likely you're okay with the most of wheels. But some wheels, only supported by Python version 2, but Python 2.7, I believe they are soon, what is that, dismissed. So you better use Python 3. But once again, this is wheels we modified for our system. But if you can't find any package you want to install in this kind of available wheels, then you have to install it by yourself. And then there could be some problem. Maybe it works fine without any problem. Anyway, this is the typical way. It's the same idea I just showed you for the PyTorch. It's the same. So let me straight to go. Let's talk about how to run. So once again, today's seminar is based on how to run. So I'm I'll try to minimize, explain what's going on behind it. Okay. Hopefully in this summer we have a summer school, and hopefully I can have one session for this parallelism for the machine learning. But at this stage, I'm talking about how to run it. Okay. So once again, we're gonna do this problem. So this is a little peek in a code, TensorFlow and PyTorch. I'll present, TensorFlow, PyTorch in parallel, so you can see what's going on easily. So there is some modules you like import it, and then checking the GPU things, you can see that. I'm just showing you I'm using this kind of code. So I'm not going to explain those kind of things. First, the thing you want to try is running interactively, which means you get the resources in an interactive mode. In SharkNet or in Graham system, I'll say there are two different modes to run your job. Technically, there are three, but running, running code without asking any allocation, we call it like running in the login node. That's not recommended or even by prohibited by system administrator. So don't run your code in the login node, which means without asking any allocation or asking any batch scheduler job. So running interactively means you asking the resources using this kind of select command. It will be shown to you interactive mode. Submitting job in a scheduler means you submit it, you don't know what's going on behind it, but you see the result at the end, right? But this one is a little bit different. You can see that what's going on one by one. That's why we call it's interactively. Anyway, so select and time, number of tasks means usually number of MPI process, which means number of uh, you know task, we say. And then I assign the 3 CPUs per task and memory allocation. And as you see here, this is the thing you have to be careful. This is the note you have to add to use what type of GPU you want to use. Okay. So as you pointed out, if you want to use a T4, you have to say T4. If you want to use a V100, you have to write down V100. If you want to use a P100, you have to write down P100. And the number two means I want to have two GPUs. Okay, so give me a second. So as you see here, if you ask, for example, here GPU T4 and let's say 5, then that's a mistake, right? Because let's say assuming you have only one node and then single node and 5 GPUs is not available, right? Then your job will not be executed because the scheduler cannot find any resource that has 5 GPUs in a node, okay? So this kind of things has to be matched well. So that's what I want to just, give you some idea. about writing those kind of numbers. Okay, so TensorFlow and PyTorch has basically the same idea. You assuming you got into the certain resources, and you have to do activate your virtual environment and just run it. That's it. It's very simple. And then once it's done, you can deactivate and you can exit from that allocation. So even though I didn't put it properly for this one, you can see that. I think the first one I took it just screen, but second one, as you see, it becomes the login node becomes a certain gram node, right? So you can see that actually the allocation happens, and I log into the allocation, which means now I'm in the certain node instead of login node. So you can exit once your job is done and come back to the login node. Anyway, that's the basic of using this system. Then how can I submit my job using the SLURM? Excuse me. Let me get some water. Okay. Um, Running and scheduler is pretty similar. So as you see, this is for the TensorFlow. So I'm gonna post my PDF to a certain location. I'm gonna show you at the end. And then when you see this kind of script, you have to know, aha, this is referred to the TensorFlow. Anyway, so left side is a single GPU in a single node, and right things actually multi GPUs in a single node. So as you see, I wrote down some, tag. So I'm gonna use T4, one GPU, but I assigned three CPUs for one task because I have one GPU job. So one task is automatic. And then I loaded some environment, and then I do some virtual environment. I move to certain location to run, and I run it. So I just type the Python instead of, as you see here, srun Python. Whenever you do the srun, it means you're doing multiple processes starting. Means previously we had MPI run as well, but MPI run is not available anymore. So srun means you kind of making or you fork multiple processes, and each process many times related with GPU job or MPI process, whatever. So you can see this kind of way. So it's pretty similar, right? And the only difference is here I ask V100 chipset GPU, 8 of them, and then I assigned one node, 8 multiple processes. So that's why I used srun. Okay. Well, you can use srun here too, but that doesn't necessarily mean right anything, right? Means one CPU job anyway. I mean one process. What I mean. And then I assigned the 24 because I want to keep like a 3-to-1 ratio. Well, you can do the 1-to-1, but um, many times CPU do some work to handle the memory side, okay? And then GPU do the computing side. So GPU, I told you, GPU is much, much faster, and CPU is a little bit slower, process-wise. So we usually assign multiple CPUs for a single GPU, so that it's kind of balanced. But how many should be better? It totally depends on your code. It totally depends on your situation. So it's difficult to say, but in general, we keep the ratio like a 3-to-1. But if you look up in the website or whatever, and some people recommend like 6-to-1. You know, it depends. It totally depends. Anyway, and then time, memory, those kind of things, everything is pretty similar. So I wrote down here in the gram system, CPU to GPU ratio, usually recommended less than 3.5. Sorry. And PyTorch has the same thing. I don't want to explain one more time. So it's pretty same, but one thing different is I loaded PyTorch virtual environment. I run it. It's the same idea. So generally, multi or single GPUs in a single node is almost the same with the interactive job. So there is not much difference. Then how can I run my job in a multi-GPU situation? First thing I want to introduce is HOROVOD. Uh, when I did similar seminar a year ago, we didn't have HOROVOD, so we need to install this. I explained how to install those kind of things. But luckily, we have HOROVOD packages in our wheels, so you can simply install it in your virtual environment by, using this one. So here is the how-to installation and environment you can set up. So HOROVOD is pretty much like a, MPI library. So you use HOROVOD to initiate the multiple process, and then you make some like a communication between the ranks. Between ranks means between cores, between GPU cores, or CPU cores. And yeah, HOROVOD is multi-platform or multi-framework things. So HOROVOD working well with the Tensorboard and PyTorch. I'm going to present you how to do it, both of them. But here is the installation. You have to activate your TensorFlow, but it's the same for the PyTorch. I'm not going to explain again. And then you have to check the HOROVOD version is 0.20 is available. And one thing you have to set in your environment is you have to write down this HOROVOD setup in your bash RC at your home directory. So library path and those kind of things has to be added. Unfortunately, we don't have a wiki page for this one in our CC wiki. So hopefully later I can probably add on it later. Okay, so here's the example. I'm running TensorFlow code with HOROVOD. So multiple GPUs in multiple nodes. So this is a little peek of the code itself. As you may see, HOROVOD TensorFlow, this kind of module imported. And then using some rank idea, those kind of things. By the way, all the code I'm showing, or all the all the Python code and the JavaScript will be shown at the end where you get it. Okay. And then this is the JavaScript you have to do. One thing a little bit tricky is, as you may see, we assigned two nodes, which means physically two different nodes, and each node must have two GPUs. And then I started two MPI process or two multiple processes in each node because each node has two GPU jobs, and each task has three CPUs. Okay. Well, you can use a six, doesn't matter. But my job is very light. That's why I decreased that. Anyway, there's some libraries that I loaded. Well, CUDA library and CUDNN, neural network library for CUDA, and NCCL. This is another library for communication. I intentionally put it here. Sometimes some code using this kind of things. That's why I load it here. And same thing, but you have to be careful. It's a parallel job. That's why I used srun and code, and where you're going to write down your log directory. I mean, where you're going to write down your log, and variable updates is using the HOROVOD. So HOROVOD will be used to update your parameters. That's the thing. So as you see in running the code, I'm going to present you where to get it. Anyway, successfully linked, and then all the devices actually found, and two different node, 1155, 1154, the two GPUs actually involved and calculate the loss. So you can see that how it's used, right? It's very simple, right? Mm. But PyTorch has more options to run in multiple nodes. Before talk about PyTorch, let me talk about the TensorFlow a little bit. TensorFlow itself has some option to run it in multiple machines, like parameter server strategy. Uh, TensorFlow has most likely, I think, 4 or 5 different parallel strategies. And then among them, one is typically used for the multiple machines, physically separated multiple nodes. The version we call a parameter server strategy. I tried to make it work, but unfortunately, I'm still working on it. So hopefully in the summer, I can present you more about that. But right now, TensorFlow is working well with HOROVOD only. However, PyTorch has many different options and it works pretty well. PyTorch first version is a distributed data parallel. This is PyTorch itself support. PyTorch also has 4 different, parallelism. Distributed data parallel is one of them. So distributed data parallel is used for the multiple nodes. There are many different things for the single node system as well. So it's a pretty much like an MPI job. So calculate the rank. Rank is the the index number for each process, and then get the starting the word. It's kind of initial. See this word side. Word means what's the size of the communication. So how many processes in the communication pool. That's the meaning. So if you are quite used to the MPI, you can understand this one very quickly. It's a very similar to the MPI programming, but it's very, in my sense, it's very naive and it's kind of tricky to make it work. Anyway, this distributed data parallel is working well in our system, but you have to do some work to make it. So everything is similar except this part. As you see, we have to know who is the main like a master so that control all the communications and everything. So we have to feed those kind of things by reading the system information, like this kind of environmental idea, what's the slum node ID and the master address, those kind of things. And you have to say what kind of init method, what kind of communication address or port will be used, what's the size of the word. So slum and task has to be read as well. And then if you run it, and then you can see that R0 is a master, 0 is a master, and then you can see that four different 0, 1, 2, 3, four different processes actually involved to run this code successfully. So DDP is very similar to the MPI, very, how can I say, the easy to understand in my sense, but it's totally up to you. If you're good at those kind of things, you can do it very quickly. Therefore, there's another way to do it easily. So PyTorch Lightning. Oh, there's a typo. It's light, not the lightning. I missed the end there. So PyTorch Lightning is another like a library or module to make it work. It's a very simple. Just reading some modules. It's tuned well for the PyTorch, so you can simply read it. And running is also simple. It's you don't see any like a kind of tedious setup for the master node or something like that. You can't see anything. I'm sure. So it's pretty much like a similar to the simple multiple GPU job in a single node for the PyTorch, right? But it runs pretty well. As you see, one, two, four different processes get involved and running well. Uh, However, this PyTorch Lightning is not available in our wheels at this moment. It was available before, but we are changing our modules these days. I think it's kind of dropped. So you have to install it by yourself using pip install PyTorch dash Lightning. Then I did it by myself. It works pretty well. So there's no problem to install it. So please go ahead. You can install it without any big problem. So PyTorch Lightning is another way to make it your job work. So you can set up this kind of very easy way. Also, HOROVOD is good for PyTorch as well. So as you see, HOROVOD torch module actually imported, and then it starts the word, and then there are long lines. I'll show you the code later. And also you need to install HOROVOD as I mentioned for the PyTorch as well, right? You have to do the pip install noise, double dash no index HOROVOD, which means you're gonna install the wheels here. So PyTorch has basically three different ways to run in a multiple nodes. But at this stage, uh, TensorFlow has only one way to run it using the HOROVOD. Okay, this is the one, and then in this PyTorch, you don't even need to say what's the parameter update, something like that. So it's pretty straightforward with the same thing. So as you see, four different cores actually working together, different node, 1154, 1155, two GPUs from each, running pretty well. You can see that. So you can easily follow this one. Lastly, hopefully I have time. Okay. Lastly, Tensorboard is a very useful tool to see how your like a loss or how your iteration goes, something like that. It's a visual tools. It's a very, very useful a lot of people actually using this one for the TensorFlow code as well. And also in our wiki page, we explain TensorBoard for the what is that, TensorFlow only. But PyTorch also has the same module to run it. So here's the way how to do it. So you're getting into the PyTorch environment, check the TensorBoard Rails. So TensorBoard is available. And I just go to and install it. Pip install no index TensorBoard. Okay. And in your code, it's a test code. And then you simply, you know, use the same idea, but you just like import this kind of modules, summary writer, and then make a some like a module and write and refresh and blah, blah, blah. But running the TensorBoard is a little bit trickier. So let me explain briefly. So what you have to do in your Gram server, you have to run your job. I based on the interactive job, but it can be running well with the SLURM job too. I mean the batch job too. So getting job work, and then you can see here, this is the node actually your job is working on. You need this information to connect some SSH secure shell connection with the Gram computer. So in your PC, you have to open the terminal and type this kind of line with the given node. This is given node. This is given node. And use the 6006, that's the port allowed in our system. And using your credential to log on to the Gram server. And then you have to do these kind of lines, getting into your, this one, TensorBoard logo directory and host 0000. And then in the background, this means background, and then you run your job. This is interactive, but in your Slum batch job script, you just need to add this one, TensorBoard thing. Okay, then and then you have to open your browser in your PC and type this one, HTTP, this one, once you made a connection, and then it will show you this kind of lines. I'm not sure you can see this one well, but on the left on the corner, there are multiple job logs. You can click it and compare it every time, how your like loss function actually changes. This is very useful tool, even for the PyTorch too. And then this is the, I think, kind of last. As you see, this log, multiple jobs actually written here. You can make sure what type of, what jobs actually has log in here, and you can compare it using this kind of graph quickly. You don't need to import and make some code. You don't need to do that. Yeah, TensorBoard can be used well. Okay, that's it for today. I uploaded all the testing files today I showed you is in this kind of website. I will post my PDF because I changed all the PDF until the last minute. So I'll post it together so you can download it here. You can download it right now, only the code, but I'll post the PDF as well. Thank you.